1.7 is on inequalities. And this is math 35. I'm setting this up so it's 2 videos because they're like completely different than math or chapter 1.6. So this is where like we've been solving equations have equal signs. Inequalities don't. But we solve much the same way. There are 2 things to remember, 2 rules, 2 differences from inequalities or equations. 2 differences. And it results in a sign flip. Results in flipping the inequality. The first one is if you change sides, move stuff around without subtracting / adding. Of course, I'll give you an example of each of these before we start using this stuff. So like if we have like x on the right is something like this. A lot of times we like to write it with x on the left. The inequality has to be chasing the x. I didn't add or I didn't subtract x over, I just moved it. Does that make sense? Like x equals 10, 10 is 1 is less than 10. If I move the 10 over here and I kept the same sign, I would be saying 10 is less than 1. If I just switch the x and y. So if we change the sign, change which side each thing is on, we have to flip the inequality. Flips, points the other way. The other option is, the other time we flip the sign or flip the inequality is when we multiply or divide by a negative. Here I can either multiply or divide by a -1. And if I do, I get x on the left, -2 on the right. And now I want to change the inequality to do this. And if you're not sure if you did it right, you can always like pick numbers that check to see if it works. So like 0 is greater than -2. So I'm gonna like test 0 here. 0 is greater than -2. And -0 is less than 2. Like that works and that works. They both work. If if like this works and this one doesn't work, then you flip the sign when you weren't supposed to, or you didn't flip your sign when you were supposed to. The barking spiders are out of force today. Let's do some examples. Oh, Sway, can I take the page away?
Not yet.
I can take it.
Okay.
Okay.
Wait, no, wait.
Just
No, I got it blurry, sorry.
fucking with me here. Like I literally asked him and he said, okay, you heard him say okay, right?
I didn't see it well, sorry.
F. All right. So let's take a look at some examples. We're gonna do -2x plus 7 is less than -5. I will start by subtracting 7 from both sides. And I get -2x is less than -12. You have two routes here. Route 1, I'm going to divide by the -2. And I get x on the left, 6 on the right. And I divided by a negative, so I gotta change the sign. That's probably the quickest way. The other way is we can add 2x to both sides, add 12 to both sides, and I get 12 is less than 2x. And when I divide by 2, I don't have to flip the sign, but I get 6 is less than x. This is not the easiest form to work with. It's easier if we switch sides and put the x on the left. Something they're going to ask you about in this section is interval notation. So how to write the solution in interval notation. If you have x on the left, this is easiest when x is on the left. I'm going to draw a number line real quick. I'll put 0 somewhere in the middle. 1, 2, 3, 4, 5, 6 is over here. And I could go up further, and I got numbers going to the left as well. All the way to the left of the line is negative infinity. All the way to the right of the line is positive infinity. Infinity isn't a number, it's an idea. It's the biggest number possible, like if there was such a thing. There isn't, because no matter how big of a number you say, I can always say, well, add 1 to it. And now we've got a number that's 1 bigger. But let's say that it was possible. This is like as far as it goes out. If you've got X on the left, we're going to start off by putting a circle on the number. And with X on the left, this acts like the head of an arrow. I'm going to do values to the right. So filling it in on a number line. If you have X is greater than 6 like this, you get a hollow circle. We don't fill it in. If we had it where there was like something underneath it, like or the equal sign, let's say X is greater than or equal to 5. If you had X is greater than or equal to 5, you put a circle on the 5. You fill it in. And then do arrows going to the right. So this is going to have a solid point. Hollow point, not solid point. Same is true on the left. If you had, like if I had X is less than 0, I put a circle on the 0, and this acts like an arrowhead pointing left. I do this. If I had X is less than or equal to -2, I put a circle on -2, I fill it in, and I point left. So again, hollow point for the thing that doesn't have the equal sign, and a solid point for the one that does. That's not interval notation, but I'm sure they're going to give you shit where it's graphed. Interval notation is taking this to the next step. So interval notation does this. For interval notation, it's important to know that, let's see, the less than and greater than signs result in parentheses. And less than or equal to, greater than or equal to, result in brackets. The infinities also using parentheses. So I'll show you what I mean in a second. But that's the unbending rules for interval notation. So the way you write interval notation, start with your pin on the left. And go, I'm going to do the X's greater than 6 right here. I'm going to do the X greater than 6 one to start with. You start on the left and then you go until you hit the line you were looking for. This is the line I was looking for. X is greater than 6. I start at 6. And if I keep moving the pin to the right, it keeps going to infinity. The line hits to infinity. I'm gonna say 6, comma, infinity. Since I had a greater than sign with the 6, this gets a parentheses. And infinity sign also gets a parentheses. The parentheses means up to this number, but not included. Don't include it. The bracket means include the number.
Up to the what, sorry?
What?
Where parentheses.
Parentheses means you're gonna go up to the number but not include it. This or in this case, down to the number. Like 6.00000001 counts, but 6.0 doesn't. Like get as stupid as close as you can, do the number, but don't actually equal the number. We don't include it. I'm gonna do all of these real quick just to show how they work. If I do the x is greater than or equal to 5, I start at the left and I keep going until I hit the 5. I hit the 5 right here, so I'll put a 5 down. And 5 keeps going until it hits the infinity. I put the infinity down. I accidentally put a parentheses there. 5 has a equal portion to it, so it gets the brackets. Parentheses for the infinity. So you can have mixed grouping symbols here. They don't have to both be parentheses, they don't have to both be brackets. If I do x is less than 0, I'm looking at this red line right here, it starts at negative infinity. And it keeps going and it goes up to 0 and it stops at 0. It doesn't include 0, so I'm going to use parentheses. And the infinities always get parentheses. If I do the same thing with -2, what do you guys think I'll get? X is less than or equal to -2.
-2 will have a bracket or no?
Infinity on -2 bracket.
I like what he was saying. Josue, we got to start with the infinity. Needs to be the negative one now. We got to have the negative. It goes up to the -2, and the -2 gets the bracket. Damn, that's right. Do not come up here. You've been warned. I mean, it smells like chocolate chip cookies up here. Please come up. Ask as many questions as you'd like. All right, let me give you guys one to try. So we're gonna have 3 minus 4x is greater than or equal to 2x plus 8. Solve and write the solution in integral notation. And I'll leave the interval notation information shit on the screen. All right, so. Who wants to start me off here?
The X is on the left side.
Put the X's on the left, all right? I'll assume that means you put the other numbers on the right. Now what?
I divided by the negatives.
What did you get?
And since I divided by the -6, X is, you flip the sign. It's less than equal to.
Yes. All right, we're at a good start. Five, six is right here. Wait, I want a negative 5, 6. That's positive 5, 6. No one gives a shit about you. So I'll switch over to red. Yeah, Jimmy.
I got the same thing, I just went to a negative 2x minus 8 and I flipped it and I put equal to 0 or bigger than equal to 0 and I flip the other side. On the right side again, I just had more steps, but I assumed that was wrong, so I.
No, if you end up in the same spot, you're right.
Saying that's
There's longer ways or shorter ways. If you move to the right,
moved everything to the left and made it greater than or equal to 0 and then moved it back to the right.
yeah, you just, yeah, you add extra work. So
So
negative
maybe-
5, 6 is right here.
Oh no, never mind.
So negative, this is x equals negative 5, 6. That's that point right there. We want x is less than or equal to negative 5, 6, which means we want values that are less than it. And we want to fill in that bad boy because we have that equal to portion. You'll see the homework tends to do shit like this, shade the line. But like if you're doing that with a pencil and you don't fucking do a thick thing, it's fucking hard to see. I don't advise shading the line. Like if you shade the line on a test and I can't see where you shaded, you're SOL. If you draw the line above it like that, it works every time. So what is the interval notation for this bad boy right here?
Negative infinity.
-5, 6. Right.
Excellent.
I just have a question, sorry. I got that -5/6 is greater than the x, but I just like flip it. I don't know if I did it just
If
the
you
different
have
way.
this,
Yeah, I did the different way.
if you have this,
Yeah.
that's fine. These are identical, these are the same. The hard part with doing this is it's
Mhm.
hard to go from here to here. It really is, like this, like. First off, it doesn't act as an arrowhead anymore, does it? Arrows should be pointing to the left. But if you did it like that, just remember when you have it this way, if you want to put X on the left, you just move the whole thing.
Okay. No, I don't get it. Like you should like go where the arrow goes down.
What?
Like if the arrow, for example, if the one you did, the arrow go to the left, it should go to the left. In the
When you divide it by the -6, that's when it flipped.
yeah, but you're pointing like the line is going to the left. It's not going to the right
Right.
because
That's
it's pointing
correct.
to the left,
The arrow should be to the left.
but the other one is pointing to the right.
This doesn't work, you can't use this as an arrowhead if X is on the right. This
So-
only works as an arrowhead if X is on the left.
So I should always organize the X in the left.
If you like to use this as an arrowhead, yes.
Oh, okay then.
And I can show you why. This is a good question it brings up. Why can't I do the arrowhead to the right? Well, if I did it to the right, like if I went this way, that is saying, well, first off, 0 is an answer. -5, 6 is greater than or equal to 0. Is that true? No. It's not. In fact, if you don't know which way to do the arrow. If you don't know which way to do the arrow. Try some points. Like I know 3 is the number I'm looking for, but do I go to the left or right? If it's over here, it would be 3 is greater than 0. If it's over here, it would be 3 is greater than 6. One of those is a true statement and one of those is a false statement. This is true, this is false. So my arrow will point or I'll shade in that direction. Using it as an arrowhead is just a convenient way of doing it. You can always do this test the points thing. Okay,
Okay, thank you.
in fact, it's gonna be really helpful later on. Testing the points is really helpful later on. In fact, we're gonna do it shortly. Alright, so 3-part inequalities. This has 3 regions. Broken up by those inequality signs. When you have 2 inequalities, we could write this as 1 is less than or equal to 6x minus 8. And 6x minus 8 is less than or equal to 4. And the and is an important part. Both of these have to be met. Or you could just work with them as 3 parts. And just like whatever we did to one side, we did to the other for the equations. Well, now it's whatever we do to one area, we do all 3 areas here. So if I want to get 6x minus 8, if I want to get x by itself, I'm going to add 8 here. But that means I need to add 8 over here and add 8 over here. So that will give me 9 is less than or equal to 6x, which is less than or equal to 12. Divide by 6 everywhere. And 9 over 6 simplifies to 3/2. 12 over 6 is 2. So our number line, we'd have negative infinity on the left, positive infinity on the right. 3/2 is 1.5. So 1.5 is right there. It starts at 1.5. And I fill it in And I go and it stops at 2. They're both less than or equal to signs, so they're both solid points. So how would I write this as an interval?
That would be bracket. We has comma 2 bracket.
Yes. Excellent. All right, so next thing in this section is quadratic inequalities. Let's see. So the way you do these is make one side equal 0. And our solutions to like the equal portion are gonna be like, I'm gonna call them test solutions. Test solutions or test points. Nope, I don't want to use the word test. What's the word they use for them here? There's a fucking word for them. Use the 0 property rule. Or 0 product rule to find boundaries. Or find your regions. You'll see in a second. And then C, test the regions. Critical points, that's what they're called. Critical points. A brain fart on that.
Fancy already.
At least it was during class. Nothing like fucking being in the car driving home and fucking talking to my wife as I'm driving home. Critical points, she's like, what the fuck? All right, I could factor this to x minus 7 and x minus 3 is less than or equal to 0. Even if there's no equal portion, even if it's just strictly less than, use the 0 product rule at this point and say equal sign. And I get x equals 7 or x equals 3. I'm gonna draw my number line. I'm gonna put the 2 numbers that are important, or the 2 numbers I got on it. At least in the right order. And then I'm gonna write a number from each of the other regions, like this region over here, like 0 is less than 3. 5 is between 3 and 7. And bucket, I'll go like 10 million. Just to illustrate, like, it doesn't need to be right next to it. So what you want to do in each of these regions is write what these signs are here. On 0, I'm gonna do 0 minus 7 times 0 minus 3. I'm not gonna calculate what it is. It's not important what the value actually is. 0 minus 7 is a negative number. And 0 minus 3 is a negative number. A negative times a negative makes this a positive region. I'll do the same thing with the other two numbers, plugging in 5. I have 3 minus, I'm sorry, 5 minus 7 times 5 minus 3. You can work these out if you want, but the important part is 5 minus 7 is a negative number, and 5 minus 3 is a positive number. A negative times a positive is a negative region. And if I do 10 million, ten million is way more than 7 or 3. So it doesn't matter what I subtract, they're both gonna be positive there. And a positive times a positive is a positive. So I've made my regions. I've used test points to find the regions. And now my solution is the stuff where it's less than or equal to 0. The less than or equal to 0 region is negative. It's a negative region. This region is less than or equal to 0. This region is greater than or equal to 0. And this region is greater than or equal to 0. Because we did the signs. The signs are telling me what signs are there. I wanted a negative region, so I want from 3 to 7. And we're filling them in. And we're connecting the dots. So we will have 3 brackets 7 as our solution. Okay. There's a lot to process here, right? So we found our critical values here. We put them on the number line and we break this up into regions around them. So like less than 3 is a region, between 3 and 7 is a region, and greater than 7 is a region. And then pick numbers that are in each region. And you just need to see if each parentheses is negative or positive. That's the quicker way. I mean, you could actually write it and find the answer. Like this would have been -7 times -3 is positive 21. The 21 isn't the important part about it. The plus sign is the important part. Here, this would have been -2 times +2. -2 times +2 is -4. The 4 didn't matter, the negative mattered. Every value that I plug in between 3 and 7 is going to generate, one of these will be negative and one of these will be positive. And once we have that, we pick our region that matches this. Let's do another one. If I factor this is x minus 4 times x minus 1 is greater than 0. So if I solve each of these, x minus 4 equals 0 or x minus 1 equals 0, and I get x equals 4 or x equals 1, these are my critical values. Those are what I'm going to put on my number line. Zero is always a useful number to check. And then pick a number that's in each region. So I'm going to use 0 here. 2 right here, and maybe 10 over here. It might be helpful to do your circling of your points right away. And filling them in if you need to. This doesn't fill in, but I can now see where my boundaries are. These are my boundaries, 1 and 4. We're testing x minus 4 and x minus 1 in each region. Here, if I do 0, I've got 0 minus 4 and 0 minus 1. Oops. Is a negative times a negative, which is positive. This region is a positive region. Then when I plug in 2, 2 minus 4 and 2 minus 1, that's negative and that's positive. So I get a negative region here. And when I plug in 10, 10 minus 4 and 10 minus 1, that's 6 and 9, they're both positive. Positive number times a positive number is a positive number. I want regions that are greater than 0. Greater than 0 are the positive regions. I want this region right here and this region right here. So I will do this. This actually gives us something we haven't seen in interval notation yet. We have 2 regions. So interval notation. We're going to do the same thing we did before. Start at the left, write down the numbers where the line starts and stops. So this left line starts at negative infinity, ends at 1, and they're both parentheses. And I keep going, and the line starts up again at 4. And it goes all the way to positive infinity. These are also parentheses because there was no equal portion. When you have 2 regions, we put a big fat U in it. This is like a capital U but wide. And it means union. Like this group with this group. All right, we're out of time. We will have more, a little bit more like this on Wednesday. Damn it, you're not where I want to be. But 1.8 is really fucking short. And can I, let's see, we're supposed to do 2.1. 2.2, I'll do 2.1, 2.2 pretty easy.
Have a good day.
Yep.